Okay guys, so we've got a long one today and we're going to look at section 5. It's been a while since we've done notes and I wanted to make sure we really knew how to do this first part of the chapter because we're going to have to apply that to the last half. So that's why we spend so much time. So on section 5, it's percent composition and empirical formulas. So we were kind of discussing two different things here. It's why it's a little bit longer. So to start off, I asked, if you got 55 questions correct on a 60-question test, what would your percent be? Because most students know how to figure out, did I get an A, did I get a B? So if you said, if you're rounding and you said 92%, that would be correct. Because what you do when you get these numbers is you would take 55 divided by 60, and that would equal, oh gosh, 0.91667, and there's more numbers. And then you're going to multiply that by 100. Or just move that decimal spot 2 spots over, and that gives you 91.6%. Or I guess it'd be 91.7 if I were rounding correctly. 91.7%. Alright, so how we do that is you're always taking part over whole. Right? You're taking your part, what you made, divided by the total, what the test was out of. Alright, so applying that into chemistry, we're going to look at the picture of the water molecules, and it says how many hydrogens are there. So just count the hydrogens at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 hydrogens. How many oxygens do I have? 1, 2, 3, 4, 5. So it says percent hydrogen in the image. So what I sometimes see students want to do right away is like, oh, 10 hydrogens, 10 divided by 5. They're just taking the two numbers and they want to divide them. But remember, when you did the test above, it was part over the total. So what are my total atoms up here? Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Or just add the 10 and 5 together. So I've got 10 hydrogens and I've got 15 total atoms up there. So I'm going to take 10 divided by 15, which is 0.667, I believe. So then when I multiply by 100, I get 66.7%. Now I normally do not write that out. I just take my decimal and I always know to move it 2 spots over to get 66.7. So you'll see a lot of times where I don't write times 100. I'll just kind of automatically do this part in my head. Alright, so anyways, that is percent. Now this is not normally how percent is going to look like in chemistry. When we talk about percent, it'll say composition by mass. So we need to know mass, which is grams, so we get that off the periodic table, right? So that's what we're doing here. It says calculate the percent composition of CO2. So I need to know carbon's weight, which if you look at your periodic table is 12 grams. Oxygen's weight is 16 grams. Now it says total weight. I am not just going to take 12 plus 16 and get 28, right? Because look at this, it is CO2. I have 2 oxygens. So really that's like saying I have 12 plus 16 plus 16, which would be 44 grams, right? So this is really 32, right? Because there's 2 of them, okay? So that's where I'm getting that 44. Alright, so now if I'm doing the percent by mass, now I'm going to take my piece of what I would have. So for carbon, for instance, my piece is 12. And then the total weight is 44. So it's always a piece divided by the total. So this is going to be 27.3. So what I did when I put this in my calculator, it gave me 0.273. I just went ahead and moved the decimal over. I multiplied by 100. Alright, for my oxygen, my total is 32. And then, my total oxygen weight is 32, but the total weight of the entire molecule is 44. So that would be 72.7, which if you notice, right, it adds up to 100. My percents are always going to add up to 100. Now, if it's off a little bit because you rounded a little weird, like that's okay, but it should be at 100 or really, really close to 100. Alright, so let's do the learning check here. What is the percent composition of lactic acid, which is C3H6O3, a compound that appears in the blood after vigorous activity? So if you'll notice that in chemistry, they give you a lot of extra information that you just don't need, right? Like I don't need a lot of that. What I do need to know is how much this whole thing weighs. So I've got 3 carbons. Carbon is 12, there's 3 of them, so that's 36. Hydrogen is 1, there are 6 of them. Oxygen is 16, but there are 3 of them, so that is 48. So this total here is 90 grams. All right, so now I'm going to go through and for carbon, for instance, I'm going to take how much carbon weight and divide it by the total. When I multiply that by 100, then I get 40%. Hydrogen, I've got 6, I'm going to divide by the total, and of course I'm going to multiply by 100, but I moved this in my head. And then lastly, I have oxygen, which is 48 divided by the total, multiply that by 100, or just move it in your head, and that is 53.3%. So if you were to add all those up, those would add up to 100. All right? Last learning check before we move on to these formulas. We have the chemical isoamyl acetate, C7H14O2, gives the odor of pears. What is the percent carbon in the isoamyl acetate? So this is a good one because a lot of times kids get really confused because it's worded differently, right? They say, what is the percent carbon? Where if you look up here, it says, what is the percent composition of lactic acid? So it's actually an easier problem. Let's work on you guys, right? Carbon is 12, but there are 7 of them, so that's 84. So, right, the first step is finding out what is the total mass. Hydrogen is 1, but there are 14. Oxygen, 16, but there are 2. So when I total that up, that is 130 grams. Now they just want carbon. So all I need to do is take how much carbon I have, divide it by the total, of course multiply that by 100, and you get 64.6%. And that is it. You don't have to do like up here we did hydrogen and oxygen. You don't need to do that for this one because they just asked for carbon. You'll have some homework that asks for just 1. If you give me all of them, that's great. That's just extra work on you. So you just need to do the one they ask for on these types of problems. All right, so let's look at this. I'm going to play this, the first part. I'll do the very first one with you. And then I'm going to be like, just pause this, watch the rest of the video, and then unpause it and pick up from there. There we go.
This is an excellent hack for multiple choice questions in algebra. Just set x to be equal to 0.
In this video, we're going to learn how to write empirical formulas, just like this, for all of these molecular formulas. Here's our first example, C8H18, which represents a compound that has 8 carbons and 18 hydrogens. To write the empirical formula, we do kind of the same thing that we do when we have a fraction, and we want to get it into its simplest or most reduced form. We look at both of these numbers, 8 and 18, and we ask, what is the biggest number that we can divide both of these by to get them as reduced as possible? Okay, so in this case, we can divide both 8 and 18 by 2. They're both divisible by 2. And dividing both of these by 2 is exactly what we'll do to get the empirical formula. It will look like this. We'll have C, and then 8 divided by 2 is going to give us 4. Then we have H, 18 divided by 2 gives us 9. Okay, so now we got 4.
All right, so what we would write here is the first molecular formula is C8H18. And he told us that it's going to be divisible by 2, which you guys have simplified, you know that. So C4H9, I'm taking 8 divided by 2 to get my 4, and 18 divided by 2 to get my 9. So let's look at the next one that he puts up here before he solves it.
And we got 9. And check it out. We can't divide both of these by the same number anymore, okay? That's how we know that this is in its simplest or most reduced form, and it's how we know that we now have the empirical formula, okay? Let's look at a couple more. C8H compound that has 8 carbons.
All right, so let's look at this next one, and it is C8H6O4. So once again, we're looking at this and saying, okay, what are all 3 of these numbers divisible by? And they are divisible by, again, 2. So 8 divided by 2 is 4. 6 divided by 2 is 3. divided by 2, and there are some like little instances where you may see some weird things going on. He's going to address that in that video. So you will need to finish filling out this. There's not room for the very last one that he does, but do the rest of them. All right, so pause that, do that right now, and then you can come back to this video. All right, so I'm going to move on. The empirical formula is what Tyler said. It is the simplest whole number ratio of the atoms in the formula, right? That's what we're doing. We're dividing to make it as simple as we could. So the learning check here is, what is the empirical formula for C4H8? Well, we're going to divide those by 2, right? They're both divisible by 2, so that becomes C2H4. So if you were to say that, then you're like, okay, well that doesn't work, right? C2H4, it's still not in its simplest form, right? So I've seen kids do this before. So make sure that you are putting it into its most simple form. So this would be CH2, right? On B, what is the empirical formula for C8H14? Now this one is going to be divisible by 2. So it turns out C4H7. Now C is doing the exact opposite. It is giving you a molecular formula of CH2O. It's in its simplest form, and it's saying what could have been its empirical formula. And the empirical formula we will talk about, oh gosh, later on. And I think I wrote empirical here. And this should say molecular. Oh, let me see. Yeah. Or no, empirical is fine. I'm sorry. They give you, what is sorry guys, I'm completely read molecular formula, got all messed up. So here's my empirical formula. They want us to find a molecular formula. So you can have more than one molecular formula, right? What if I multiplied this by 2? What if I multiplied it by 3, by 4? I could get a bunch of different molecular formulas, right? So which one of these would work? Well, this right here gives it away. That means that I cannot have, these cannot be the same. So I know A is not it. But look, if I multiply this by 2, I get C2H4O2. So this is a possibility. But if I multiply it by 3, I would get C3H6O3, which would also be C. So B and C are correct answers for that. All right, this one tends to give kids a little bit of issue in previous years. And it says a compound has an empirical formula Sn. If there are 4 atoms of nitrogen in one molecule, so it's saying that you have N4, what is the molecular formula? Well, if this goes from a 1 to a 4, I multiplied by 4, right? So that means S also has to be 4, right? So basically all I'm saying is, how did I get 4 here? Well, I had to multiply by 4, so it's S4N4, okay? Now let's look at how we find these. Like if they give us a problem and they're telling us, oh, you have this much of something. All right, so let's watch this quick video here on the steps, and I'll pause and we'll write them down.
An empirical formula is an educated guess or an approximation as to how many elements are within that chemical compound. It is not the exact chemical formula. All right, there are multiple steps, so let's jump right in. An unknown compound contains 68.4% of chromium and 31.6% of oxygen. Find the compound's empirical formula. First step is to change your percentage to grams.
All right, so let's write that down. Our first step, let me get rid of this right here. I'm going to put this up as high as I can get it. Step 1 is to change percent into grams. Now this tends to not change percent. Be my first step, really, because I'll have them write this down on their periodic table. I tend to not use this. I just know right away when I read a problem that my percent is now going to be in grams.
The reason we can just automatically do this is because if you were to add both of these numbers together, you would get 100%. So this entire compound or percentage is out of 100%. There's no need to convert anything. Literally change your percentage to grams if this is out of 100%. This is what we'll be using to do our next step. Step 2 is to convert your grams to moles. We'll use...
Okay, so step 2, grams to
the grams from our previous step, changing that to moles using the molar mass as your conversion factor because we're going from grams to moles, aligning those grams across from each other so they can cancel, and then we'll divide and we'll get 1.315 moles of chromium. Do the same exact thing with oxygen's molar mass. Divide these two values and we'll get 1.975 moles of oxygen. Our next step is to divide by the smallest number.
Alright, so I'm going to write divide by smallest number of moles.
So our smallest number of moles was the 1.315 moles of chromium. So we're going to do this for each moles, and that'll just cancel out our moles, and we'll get some sort of subscript. So we now have 1 for chromium and 1.5 for oxygen.
Okay, so here I'm going to talk before she gets to step 4. Step 4 is not always a thing. Like you saw where she had 1.5 moles, and I can't have like half of an atom of something. I couldn't say, oh, I have 1.5 oxygens. That's not a thing. So in this case, she has to do step 4, and I'll show you an instance where we don't need step 4 and another instance where we do.
Next step is to multiply these numbers, these subscripts, to get a whole number. So
Okay, so we're going to multiply to get a whole number.
in our case, we have 1.5. We have a decimal ending in 0.5. So whenever you have any sort of decimal ending in 0.5, multiply each subscript by 2. There's another rule where if our decimal now ends with 0.33 or 0.66, multiply each subscript by 3. If we then have our decimals again that end in 0.25 or 0.75, multiply every single subscript by 4. So that's why in this case, we're going to multiply both of these subscripts by 2 just because of this 0.5 value, and that was the rule. So our final answer for our empirical formula would have been 1 times 2, which gives us 2 chromium, and 1.5 times 2, which gives us 3 oxygen. This is our empirical formula.
Okay, so the multiply rule, I'm going to write some of those down that she said. So she told us that if it's 0.5, we will multiply by 2. She also told us that we have 0.33 or 0.66, we're going to multiply by 3. And then she told us if we have 0.25 or 0.75, we are going to multiply by 4. Right? So if I do steps 1, 2, and 3, and I get 3.25, I'm going to have to multiply not just that one, but all of them by 4, and we'll see one here in a little bit. I have some other numbers down here too, like if you have a 0.2, you're going to multiply by 5. I think that's the only, a 0.67, you'll multiply by 3, which is close to 0.66. So anyways, we cannot have like 0.66 of an atom. Okay, it doesn't happen. All right, so what I will have them write on their periodic table is basically just step 2 and 3. So on theirs, I will have them write, empirical formula, step 1, grams to moles, and then step 2, divide by smallest. So I'm expecting you to know step 1. Just change your percent to grams, and I'm expecting you to know that sometimes you may need to multiply if you don't get a whole number. So I will have them write that down. Of course, the periodic table in normal years, any year, I always let them have that out for every test, every quiz, except that one we did in chapter 4 where you guys had to know the symbols. All right, so let's look at a learning check. Let's do this then. We have a compound contains 7.31 grams. Now, they didn't give us percents. They went ahead and gave us grams in this case. And 20 grams of chromium. Calculate its empirical formula. So, first step is going from grams to moles. So, I have 7.31 grams of nickel. So, let's see here. Nickel is, if you look at your periodic table, it's 59 grams in 1 mole. So, when I take 7.31 divided by 59, I get point. Now, this is one of the can. If you just round to 0.12, it could mess you up in the end. It could give you some weird number here when you don't need that weird number. It's happened before in the past to students. So keep as much of this as you can. So 20 grams of bromine, change into moles. Bromine is 80 grams in 1 mole. So 20 divided by 80 is going to be 0.25. Now, the next step is to divide by your smallest, all right? So I'm going to be dividing by this big number here. And I don't always write this out, like in my head, I know I'm dividing by my smallest number. So I'm just doing this so you can see exactly what I'm doing. But yeah, I'm like, ooh, I don't always want to have to write these big numbers out again and over and over. So when you do divide this, this is 2. So now, what this is telling me is that I have 1 nickel and I have 2 bromines. So I have NiBr2. See, in this case, I don't need step 4. I don't have a decimal, so I'm okay. And if my decimal is like 2.01, like that's okay. 2.02, that's all fine. Okay, so let's look at the next one here. Here's just a chart with a few more. It's showing you the 0.20 there. So that one's got all of them. I think that might have all of them but the 0.75 on there. Alright, so let's do these, this last layering check and then we will be done. So aspirin is 60% carbon, 4.5% hydrogen, and 35.5% oxygen. Calculate its empirical formula. So remember, the first step is changing those to grams. So 60 grams, 4.5 grams, so carbon, hydrogen, and 35.5 grams of oxygen. Now step 2 was to change this to moles. So carbon is 12 grams and 1 mole. Hydrogen is 1 gram and 1 mole. And oxygen, 16 grams and 1 mole. Alright, so when I do this, this is going to give me 5. I'm going to, this stays at 4.5, and this is going to be 35.5 divided by 16, which is 2.2187. Remember, I'm going to keep all that. Normally, anytime throughout the year, I've always been like, oh, 2.2. Well, this time around, I'm going to keep it all to make sure that when I do this third step, it doesn't mess it up. So when I divide by this big number, that's going to make that 1. That is going to make that 2. And this is going to make this 2.25. Now earlier on the previous problem, we were able to stop here, right? We had NiBr2 and we were able to be done. Well, this time around I can't. I have to do step 4, right? I've got this right here, this 0.25. I cannot have a quarter of a carbon atom. Like that doesn't happen. Like, oh, I only have a fourth of a carbon. Can't happen. So if you look up here at this at 0.25, it tells you to multiply by 4. And it's not just carbon. You cannot just multiply carbon and be done. You have to multiply all of them. That is something I've seen in the past that students have messed up on. Alright, so this really then becomes 9, this becomes 8, and this becomes 4. So what I have is C9H8O4, and that is my empirical formula. Alright, so this is my true formula for what I have. Alright, well that is the end of those notes of section 5. If you have any questions at all, let me know. I know there's a lot of math, a lot going on. So just let me know if you need anything. Have a great rest of your day. Bye.